Let's learn about the volume of prisms and cylinders. So on our agenda, we're going to start by comparing the surface area formulas and the volume formulas. Then we'll look more closely at the volume formulas for prisms and cylinders, and we'll do a couple of problems together. Let's get ready. You'll need your notebook and pencil and a calculator. And let's just start by comparing. So surface area, you think about the wrapping paper on the outside. So I would find the area of each piece, all 6 sides, and then I would add them. So you're adding after you multiply. With the volume, you're filling everything inside. So you're thinking about the units, thinking about the area of the bottom, and then really thinking about the height as you fill that up. If we think about the units, because we're finding the area here, this would be centimeters squared, and then we're adding, these are all going to be units squared. But if we had some units here, let's say that these were inches, I'd be doing inches times inches times inches, which is inches cubed. So with surface area, it's units squared. With volume, it's units cubed. Let's get into the formulas for the volume of a prism. Remember, you name a prism by the shape of its base. And if we look at our formula, we have volume equals capital B times H. When it's a capital letter, something has been done to that. So this capital B really means the area of the base. So the volume is the area of the base, whatever shape that may be. Maybe it's a rectangle, a triangle, a hexagon, a pentagon, times the height. So if we look at these shapes, we're going to call this bottom, the 5 by 2, that would be our base, and then 3 is going to be our height. And then when we look at our triangle, this is a triangular prism, and the triangle itself is the base. So we're going to do the 7, and the 24, and then the 22 is going to be the height because that is the distance in between those two parallel bases. And then our last one, we have a hexagonal. So we're going to have to do the hexagon for the base. And then the 3 is going to be our height. So we'll take a look at each of these. So in example 1, we said that we're going to have this be our base and this be our height. So we're going to do the volume of the base. So that's 5 times 2 times the height, which is 3. So really with a rectangular prism, it ends up being the length times the width times the height. You're multiplying all 3. You can do it in any order. And we get 30. And then we're going to say cubic centimeters. Finding the volume of this triangular prism, again with the capital B, and this time our base is a triangle, so we have to remember the area formula for a triangle. So this is going to be volume equals 1/2 lowercase b for the base of the triangle and lowercase h for the height of the triangle times the height of the prism. Don't let those h's get you confused. They are different. I'm going to put little triangle there. So we have 1/2. The base of my triangle is 24. The height of my triangle is 7. And then the height of the prism itself is 22. Again, this is all order of operations. It's all multiplication. You can do it in any order. You can do it right on your calculator. You should get 1,848 meters cubed. Let's find the volume of this hexagonal prism. It's a hexagon because it has 6 sides, and it's a little more work to find the area of this hexagon. So the 3 is going to be our height. The 10 is just going to be one of our sides. So if I just draw the hexagon, nope, I want to go like this. I like to draw mine like this so that, that I can draw my triangle there. And then if this is 10 and it's a hexagon and we drop the apothem, which is the height of the triangle, we have a 5. And then because it is a hexagon and all the sides are the same, that's a 10. We have to do a little Pythagorean theorem there. So we're going to do a squared plus 5 squared equals 10 squared. A squared plus 25 equals 100. Subtract the 25, we get 75. Take the square root of that, and we get about 8.7. That's my apothem. Remember the formula for area of a hexagon? Oh, goodness. Area equals 1/2 AP. So we found our apothem. Now we need to find the perimeter. Well, that's going to be our side times 6, so we're looking at 60. So now we're ready for this. So our volume formula for a hexagonal prism is really 1/2 APH, because that is the base formula for the hexagon. So when I plug this in, I'm going to get 1/2 my apothem, which is 8.7, my perimeter, which is 60, and my height, which is 3. And you should get about 783 cubic inches. Now let's switch over to the volume of a cylinder, and when we compare these formulas, we said the capital B is the area of the base, and that can be whatever formula we need, the triangle, the trapezoid, the hexagon. Well, that's what we're doing with the cylinder. We know that the base of a cylinder is that circle, so we're going to use the circle formula for the area, and then multiply it by the height. And remember, the height is the distance between those two circular bases. So find the volume here. Well, the 12 is going to be my height. The 8 is my diameter. So I don't want to use my diameter. I want to make sure I cut that in half and use my radius. And so the volume is going to be pi. My radius squared is 4 squared times my height, which is 12. I'm going to multiply the 4 squared times 12 and get 192 pi. That would be my exact answer. And if I multiply it by the pi to get the decimal, I get 603.2 centimeters cubed for my answer for the volume of that cylinder. So volume of a prism is a capital B. You use whatever area formula you need to, and if one of those areas is a circle, you're finding the volume of a cylinder. Nice job.